Right. So in the repository, in the folder lab, you have indices, the notebook that's there. We're going to work in that notebook. So from the lecture about that you just had, we were discussing inverted index. How is it built? And you saw that you can, from a list of documents that we have to extract all the tokens to build the vocabulary of the document. And for each term in that document, we're going to build like what we call postings, like which is the documents that contains this particular token. This is basically the inverted index data structure. However, in order to build terms that we're going to extract from the document, we should find a way to extract correct terms. This means that we also consider, for example, normalizing the tokens that we extract from all the documents, okay? Such that we will first have like less amount of terms after crawling all the documents. And then they will be connected to the posting list, which are the documents that contains this particular term. I hope this is clear for everybody. Otherwise, we can have whiteboard session, discuss this, and then go back to the code. Okay. So you have this pre-processing step where we are basically gonna prepare the code for tokenizing, normalizing our tokens from the text that we have. So we have stop words. Stop words are words that we will that will occur more often in text that we're going to use. For example, this word will be more present in the text or the documents that we're using. However, these documents can also, these terms can also be less relevant for the request because we can find these stop words in a lot of documents. So we should pay less attention to these terms. And then we have the stem. The stemming here will help us to like extract the right token, such that if you have the variant of a word, you can use just the, you can remove like the suffix part or the prefix part. Just save the word itself. Is it clear? So we're gonna use the stemming as well. So we have the first function that you're gonna fill in there is tokenize. So you're giving the text and you want to tokenize it. So you use the NLP toolkit for tokenizing. So this should return tokens from the text that we have. Then we have stemming. From each of these tokens, we're going to apply the stemming there. So here we use the Porter stemmer. You can read the documentation for more details. And the other function is appropriate word. So we want to make sure that the token itself, it is not a stop word, and it's also alphabetic token. So in that function, you are expected to return true if the word is not a stop word and it is not and it is alphabetic word. Is it clear?
I'm not sure.
Is alpha. Yeah. It's alphabetic. So if you have, for example, if it's alphanumeric word, okay. Yeah. And then the last step, you're going to combine all these pre-processing operations, where we first tokenize the text that we have. After tokenizing, we apply the stemming on each word that is appropriate word. So this is what we expect to return from this pre-processing step. Does that make sense? The last function, pre-process. This function, we're going to use it because every time you have the query, you have documents, you have to pre-process query and documents together using the same pre-processing function. Mm-hmm. So in this pre-processing function, you're going to combine all the steps that we had previously. First, you tokenize the text that you have. Okay. Next, you perform the stemming, and then you perform the stemming only on the words that are appropriate words. Okay. So you're also filtering out the non-appropriate words. So when this is done, let me know if it passes the test, if you have any issue. Yes.
What do you change in the pass function?
Change what?
In the pass function. And that's in HTML document, to you change the method pass. What do you like?
I think that you can just reuse there.
Second?
In the description, what a minute.
It gives the reason to change, but not exactly how it should work. So it isn't, we don't want to pass the whole page, but it doesn't say what happened.
Like when we are crawling a web page, for instance, okay, sometimes we do not want to pass all the links that are inside. So we want to pass the links that belongs to the website, like the original website.
I will use it. How many just pass it?
Do you have an answer for that? So in the tokenized method, I guess all you have to do is to use the NLP toolkit with word tokenize. Okay. So this will return tokens for you from the text. Okay. And then for the stemming, we have self.the stemmer dot stem. We're going to stem the word using the stemmer that is provided. So we use the stemmer that is providing parameter. Does that make sense? And finally, you have to check that the word is appropriate word, that the word is not a stop word, and the word is also alphanumeric word. Okay. So here you have to return if word is not in. We have the list of stop words here that we have enumerated there. So if it's not in self dot stop word, and since the word is a string, we can just take that this is alpha. Does that make sense? And finally, final step, you have to combine all of them. So we have a text. When you have the text, you have first to get the tokens. So we call our self.tokenize on that text. Maybe I have to pass to Zen mode such that you will see. Well, so first I have to retrieve the tokens. And for each of these tokens, I have to perform the stemming on them, okay? So I have to call self.stem on the token. And then I get this token from the list of the token. Okay. But one last thing is that we have to make sure that this token is valid. It's appropriate word. Okay. So I can add if share token or self that is appropriate word of that token. And then that's it for the pre-processing step.
Can you say that?
Set what?
Stay up.
Okay, we have an error there. Yes? So the stemming functions also needs the stemmer that we have. So we have self dot author stem in the stem method. Does that make sense for everybody? I guess I have to install something missing.
Yeah, you need to, you're not scared on all ones.
Yeah.
And like the stop words, we have stop words in MTK, right? Why do we use the stop words that we wrote?
These are our own stop words. Or not question.
We should add forward.
Ah, yeah, that's true. So one thing that we should do is this dot lower. We should lowercase our tokens. Very important. Make sure that everything is normalized.
What did you change?
Because without normalizing, if you have two tokens that are different from just capital or lower letter, they'll be considered different, right? So we lowercase everything. That's also a mistake that I saw in some of our assignments. Or some of you forget to lowercase tokens that you're building. If you forget to lowercase the same token but differ with just one bigger letter, consider it as different tokens.
Yeah.
Okay. So very important to
Can you
to
spell
lowercase. Yes, sure. Okay. Oh, wait. What happened? Yeah. I can zoom out also. Is it clear for everybody? If there's no question, we move next. So next we have to crawl and index website. You know, the search engine needs to index documents. After indexing a document, we can then query those documents. So for that, we're going to implement a crawling where we are given the link of a web page. We're going to crawl this web page and index all the documents that are inside that web page. However, this code shows you what we did last week, also in the assignment, where you have HTML documents. We will need to extract all the links that are inside the document and also the text that is inside that document, right? But just the previous code, what happens there is that we just extract all the text, even the text that is not relevant for us. Just imagine that we are trying to crawl like article website, okay? When you have a given article, we know where's the text of the article, the title and the content of the article. But if you just crawl like getting all the text of the web page, you'll also get the menu, the footer page, all these things that are not relevant for us, okay? So here, that's where we have to modify the parse method to extract the text only where it is relevant for us. Does that make sense? Then let's follow this website.
We have to filter out the scripts.
Yes, so let's open one article. For example, for this particular web page, Oh, this is fake news that are working. So we have the title. No, not fake news, but the most hot topic now. And we have the content here, right? So what we can do, we can see why can we identify this title? So if I inspect this, I can see that the title is located, it's having some text heading to, right? So I can use this information to extract the correct title. What is relevant for us is the title and the body of the article, not all the other information that are around there. Does that make sense? So instead of getting, instead of saving all the content, like if you see where we get the text, we find all text true, right? We instead extract the header and the content of the article. These are the text that we're going to save, not all the text that are inside the page. Does that make sense? So try to get use of this information in the DOM to extract the correct part of the document that is relevant for us. Okay. So modify the parse method and then consider this comment. Yes.
Do we need to include some specific tags or like exclude the irrelevant tags?
Like if you remember Beautiful Soap, we can, for example, extract this header, okay, and the text that is inside the body of the article. All the other text is not relevant for us. We just want to crowd the content of the document itself because this information are repeated across multiple pages. So if you are looking for, let's say, for example, if you are looking for Russian, Ukraine, conflict, you will not find it in the corner or in the menu or all this stuff. It will be either inside the header or the content of the article, So that's why we are just extracting this text. Because remember last time, when you call find all text true, it returns all the tags that contain the text, but this text is not relevant for us.
Yeah, I know, like, should we like select?
Yeah.
And body tag?
Yeah. Yeah. You can inspect the DOM and then see which blocks or which tag contain those parts of the document. Okay, and then you use it to extract. For example, if you inspect here, if I inspect this one, I can see that it is inside this block. Make sure that it is the same across articles, or you can get the global blocks that contain them, or you can get just this one. And you see that they have like class, heading, header 2, and some random things around. Okay, so you can get the header first, and then you will try to extract the body. See which block contains the body itself. So you can see that we have here article body.
So the parse thing is just the same parse that we did in previous one?
Yes, but just now we are not interested in all the text that is inside the document, but some part of it.
Yeah, just we can change the eliminate part, like from style script head title document. We can change it
To what?
Eliminate everything except the body.
Except the body?
Except the body and the head.
No. If you say except the body is everything that is inside this document, this page. The body is itself, because look, even if I check this header, it is inside the body. So we also return this text inside the menu. Okay. So instead, you can just extract, get tag by class or something like that, and then you extract the text that is inside here. So What does it mean? This means that you should retrieve the diff with the class, with this particular class.
Can you zoom?
I can try to zoom in, but I'm not sure.
Where class is article body content
Yeah,
and the header is.
and the header, you inspect the header, and then you use the same thing to extract the header. So you inspect here. And then you choose one of them, which is the same across different pages, and you use it. That makes sense?
So we need like to select.
Yeah, so you select this header and the body, okay? And after that, you merge them to one text.
So.
So try to update the parse function. Instead of getting all the text, select first the header of the text, the header, and then
So
the
we're
body.
going to change only the last 3 lines.
Yeah. I'm not sure. Yeah. Mhm. Just one last comment from also as feedback from your assignment. When you are tokenizing, make sure that punctuation does not fall in your tokens. Okay?
You can remove stop words and
Huh?
punctuations. Removing stop words and punctuations.
Removing what?
We can remove the stop words and punctuations.
Yes. So when you take this work tokenize, it also implements this for you. But if you are going from scratch, make sure that you also skip those punctuation. They are not tokens. Okay.
But in the language part, I remember in other languages, the punctuation can be part of the word.
Yeah, that's why sometimes we tokenize with respect to the language that we consider. If you're implementing your own, it's also going with the assumption of the grammar of the language that you're exploring. Yeah. Also the stemming step, where you can see like we have retrieval, when we perform the stemming on it, we just keep with retrieve. Okay. We see that if you have like all the variation of a given word, we just keep one part of this because it's the same meaning. And we use it as our token. Okay. So if you are looking for example, retrieve information, a document that contains retrieval, it's also potential answer to the query, right? That's why we should like try to perform the stemming.
Question marks, what about apostrophe mark?
This is
laptop apostrophe there.
just laptops.
JOHN and apostrophe S.
In most cases, it will be skipped. Yeah, in most cases, it will be skipped. But when you see another way of representing text, for example, word and reading, you see that like, you have a meaning when you transform word into a vector. So we connect John's to the next word that is there. So you expect to change this text. It shouldn't be all the text inside the document, but just the text that is inside the header and the body of the document. Who has finished? Just share your solution. So share what I expect from you is to extract the header. We should extract the header and then the body. By body, I don't mean the tag body, but the div that contains the content of the article. Okay. And then you can combine them and apply the same filter. Maybe they are script insights. If they are this tag filtering, maybe they are style, script, header, title, everything there, we skip them. And we just find all text in the header and the body. So let me know when you have this done. Meanwhile,
Sir, like the class of the header is gonna be what?
The
Media
class-
story car?
yeah, you inspect here.
Yeah, like there's multiple classes, like especially we're not gonna take this kind of class.
I think
That-
we need to take the class because there's only one head. Like you can
The
take
real
the
class is
class
the article header.
You can just take the header.
For example, here you can see this one looks more the same across all the documents, all the articles. Okay,
Yeah, but it might different in another website, right?
another website? Yeah, sure. Modify another website.
So can we yes. So one thing that like the body of this news, where can I find the body? Like
If you inspect here, this is the
no,
body.
like some kind of news, they don't have this thing.
You know of what?
The one with the tank picture, it has like a very small body. Like recruiters.com, you go to like the main page.
But we're going to crawl only articles.
We need to.
In the next crawler. Now it's a document. When you have one document, how do we extract the content? Okay. In the crawler, we specify which kind of links we want to crawl. Does that make sense?
Yeah, like because it might define what.
In the crawler, we specify that we just want to crawl pages that are articles. If you check from here, you can see that we have like this pattern, which tells us which kind of page we want to crawl.
Yeah, like but if you went to the main page, like
Yeah.
just recruiter, yes.
Yes.
Yeah, like with the tank, underneath the tank, there's a text. See the small text up
Why?
underneath the picture of the tank.
Here,
Yeah, this text.
we are not crawling this object itself.
Like because like from 1 minute you showed this thing, and I thought that we need also to.
No. Look, we go from this web page. This is the initial page where we start crawling. We extract all these links that are articles. Okay. And for each of these links, we're going to extract the header and the content as the text.
Yeah.
Okay. This is the next task. Inside the crawler, this is where we're going to make this restriction.
So
Which
we need to
page?
change also the anchor finder.
The anchor,
The anchor finder.
not yet. Just keep all let's just keep all the links. But while crawling, we restrict ourselves to the links that start with. Okay.
So like we just need to.
Yeah, so if I come here, I can take H1. And even if this class looks like generated to me, hopefully they will not change across links because some websites do not want to be crawled. So they generate this DOM dynamically. That does not look, okay. It seems like header 2 makes more sense for this particular page. Okay, so if I choose this one, this is the header. I come back in my code and I will say
What does it find?
soap.file. I can specify and find H1, right? With class.
Why are you not using select? Also more, you shouldn't use more.
Use what? Yeah, model.
Your class should be in quotes as well.
This is the HTML. And then we have the body. We can also use select, okay? And you specify the attribute. So there are multiple ways of finding that. So now to extract the body, we come here, we inspect this, and then we see that the body looks like it is inside this div. With this weight naming convention. So here we will select div with the class, with this class. There is no dash at the end. Yeah, with this class. Okay. And the text itself will not be
Can you tell like how did you find it? Like that?
I-
Because there were multiple classes.
I inspected this, okay? and I check the parent, and from the parent, I can see the class here.
I know, but for the header has multiple classes.
Header has multiple classes. Yeah, I chose the one that looks to me like the most close to this particular tag. But again, it has like the tag H1. Okay, so combination of H1 and this particular class will give you the header. That's why also for SEO, when you are indexing your website to Google, there are meta tags that you need to specify inside your web page. If your page is article, you specify that it is article. Where is the header and where is the content of my article? You will not have to go inside each pages and try to extract those information because they will be provided in the meta tag. Okay. By instance, we can check whether this particular page satisfied that. If you go to the header, you have script, and then you have meta. Okay. For example, in meta, we have property OJ title. This is the title of the article. This should be common for all the article pages. Okay, the meta with the property OJ titles. Okay, so we can extract this title from share. And also we can see the description. We can also extract the description from share. We will not have to go for this particular website to extract it there or there. Okay, so if this OJ, you have also OJ type that tells you that this is an article. So those metadata can tell you which part you want to crawl or index or no, and what is the type of the page that you are indexing. Okay.
Also for the snippet we use.
Yeah.
So
So
go back to the code.
right, sure.
Yes, and now we should say.
Yeah.
We're
So-
going to use the visible text from. Like what you are going to do with the header and body? We're going to use them instead of text, right?
You can merge them. Okay. You can merge them and find all text.
Should
And-
it be like just before merging, like select the text?
We can select the text before merging. Okay. So you can have, for example, header text. You call header, and you find all. And you find all text equals to, okay. And you do the same for the body. And then you have
Change the header word. Like body.
yeah, body. And then finally you have header plus body text. And then this one will filter out if there's invalid like script or style inside.
Maybe we're not going to need this filter anymore. Because like
May-
we are limited to this.
Yeah, maybe, but so nothing avoids us to add script anywhere in the HTML.
It's not going to.
It is just recommendation to add the script in the header or in the bottom. Okay. So again, the question that you asked before, you said that we are not going to crawl the same page every time. What I was explaining is that for the SEO, for a particular type of pages, we have metadata for each page. And we can extract that information from metadata. This metadata is supposed to be the same across websites. So if you are building your news website and you want your website to be indexed by search engines, we should also include those metadata information.
So this thing is gonna be uniform.
It's gonna be uniform. So instead of extracting the body from a particular class that can be changed anytime by the owner of the website, we extract it from the header. For example, if you go in the header, you have the metadata. You have, for example, metadata type. It tells you that it is article. Okay, and then you have metadata OJ titles, and in the content you have the title of the article. I can zoom in, maybe if you don't see properly. So instead of extracting as we did before, we can just read this meta information, and we are sure that this will work for any article website. Okay. You have the URL of the web page, and you also have the OJ descriptions. Remember, when you share a link on Telegram or any other website, it gives you a snippet of the content of the link, right? This snippet is extracted from the meta information. And also you have the snippets of the image. This snippet is obtained from share, oj.image. You have the direct link to the image of the website. So if I just open this, I will have the snippet of the image that is inside the website. I can print it anywhere.
So you can like take the pictures also.
Yeah, you can take the picture, you can take the title, you can take the description of the
So
link.
this thing is the metadata, so like search engine can make it pop up
Yeah.
inside the search.
Exactly.
results.
Exactly. So we can also get use of this. But this meta description sometimes is not the full description. Okay. So the full description, you can get it straight from the content itself.
But like that's why like sometimes it's gonna be different to get the real body. Like, it's
Yeah.
might differ between website and another.
Exactly. So when this is done, we can just run this and make sure it works. There's no test there to pass. Next comes the crawler. What? Yeah.
Like in this case, I use like select or need to include that in the same thing.
If you use select,
So
if this is select, you have to specify by what are you going to select.
Yeah, I mentioned like
By
expert
tag?
class, blah, blah.
Yeah, if it's by tag, and then you also specify the attribute,
like did
the
you-
parameter attribute class, and specify this particular class.
this class, the first one, is it the full class? Or it's like it took only like piece of the,
I took one class inside. Okay,
just go back and gain like.
to make sure that it's the correct one. Also, look, something that I will even advise is that here we can just get this title from the meta information. Okay. So I come back, I have H1 and I have the class here.
Yeah, this is the class.
This is the class here.
This thing, this part is only the class.
There are multiple classes. I chose one.
You chose one, so
Yeah.
I can only take this heading 2 to 4.
I chose one. So if this is done, let's move to the next task. Okay. Is it clear for everybody till here? Yes.
Here you didn't use them like for the header and body variable here.
Yeah.
You use it for a specific website, right?
Yeah. This class is for a specific website. I told you how to use it for any class.
Any class was supposed to fill in with the metadata.
Yeah, with metadata. With metadata, here we specify meta.
Yeah.
Okay, here we specify meta. We come here, we make sure that we're having the right metadata. So for example, here we have metadata with one property. Let me find it. Okay, we have metadata publish time. We have metadata. It's not here. Okay, right. It should be somewhere. Okay, sure. We have title, right? So we can select here with property. Property. You see property. And here we have OJ title. So, yeah. So if we have this, right? But this will return like an array, okay? So we can just get the first one. Okay? You can also handle error to make sure that it exists, and then you get the first one.
Because that will return a list, right?
Yeah. For example, if let's say if length is greater than 0, okay? So we set the header, or we set header text will be header of 0, okay? Dot you can just call get and specify the property. What is the property? Is content, right? And specify content here. Okay, and else you just specify that the header is none. or we specify that the header text is empty string. Okay. So, and then here we will not have to merge this. And we remove this.
We get content.
I don't think it's going to work because find does not return a list. Find all returns a list. Find merely returns the result. So I'm not sure why.
Find method tag and set domain. It returns what?
Find all returns result with everything that we get. Find return since we only it returns only one, so that satisfies.
This is not final.
Yeah.
Yeah. So if this is not final, yeah, you're right.
Yeah.
So we're gonna just make sure that this is correct. Otherwise, not no. Why is it not highlighting this text as it is not gonna be executed? Yeah. So we have this. Yeah. So here we can also concatenate like the visible text. Okay.
Why not taking the 0 part?
Taking what?
Like you previously take the first thing, but now no.
It's not a list. It's not find all. It's just fine. Thanks for the reminder. So here we can then, let's say, just merge. Right, we can merge the header and the visible text. Does that make sense?
Why?
So text here should be body. So this is just another way of extracting the title. Okay. So if this is fine, let's move next.
Just 1 second. Like, why did you put the 2 curly brackets?
I'm just concatenating this, the header and the content and the body
Yeah.
as a block of text together. Well, so let's move on. So next we're going to build the crawler. Our crawler is basically going to find all the articles, okay, and save them inside a collection of path. So we have the collection of path to all the articles that we have. Also, we have to build the inverted index for those documents, okay? To build the inverted index, we have first to pre-process all the text that we get, build the stemming or the tokens, since the inverted index is based on the tokens, right? And then we build the posting list. If the document contains the token, we add the document index ID to the posting list of that particular term, okay? And so on and so forth. So for that, we have to complete the code for the crawler. As we did last time, inside the assignment, we have to implement the BFS, where we also have like the source node, the max depth, and the collection part. So this is the folder where we're going to save the collection of documents that we're going to retrieve. Okay. So we perform BFS to extract document, but one restriction: you will crawl a page only if the URL starts by this one. Okay. So you have string dot start with. If it starts with this, you add to the list of the page that you will visit. Okay. If it is not, you just skip it. For each page that starts with this, what we do, we build the HTML document of that page. Okay. And then we will also build the inverted index.
One thing, sometimes we get the link as a sublink.
Yeah.
And we didn't fix this thing here.
It is fixed already. We have the normalized link here. and the normalize will merge both.
Ah, yeah, I didn't find it.
Yeah. So go ahead and implement the crawler.
You can use the same problem.
Yes, we can use the same crawler, but also here before exploring any links, make sure that it starts by it is an article. The page is an article. When it is the case, you then build the HTML document that will give you the links, the images, and the text. Okay, the text here will be the header and the content. From there, we have to index this particular document. Okay, and here you have our index. Okay, so first build the crawler, and then we will discuss the index step.
So like the thing that is gonna start with is the
It is this.
only this way, this
Yeah.
way, this
Yeah,
like, so it's not dynamic.
it's just for this particular page. Yes.
So we just need to crawl them, like get the documents and store them, right?
Yeah.
Because in inverted index.
In you have the field doc URLs where you will store document ID and the URL. Okay. You have the index where we have the term, which is pre-processed already. Remember our pre-processing step. Okay, those are the tokens that we have from the pre-processing step. And then we have the collection frequency, how much, in how many documents this term occurs. Okay, and then you have the posting list, or you have the document ID and the doc frequency of that document. Okay, and so on and so forth. And lastly, you have the document length. For each document, what's the length of the document? And you see this code here that we will save this in the, write this in the disk first. So we store the list of documents that we have. We also store the inverted index, and also we also store the document length. Okay, so you have to fill in all these methods. And here you have the index document. For the index document, you have the document and the document ID. Okay. Yeah. So go ahead and implement the crawler.
What is the collection path?
Is the what?
What is collection path?
Is where you're gonna save the folder.
So like the crawler is not gonna use this thing, right? Like the crawling method is not gonna use this thing.
No, it's just where you save.
Yeah. And what is the document length?
What's the what?
Doc length.
Is the number of terms that you have inside the document.
So inside the crawler, for each URL we are going to find with open doc, document URLs.
Yes, we don't need to worry about external pages. Right?
Don't need about what?
External pages.
Because it's gonna start with this thing.
Yeah, yes. That's right.
So last time we used yield, but this time for each link, what we're going to do?
Last time we did what?
We like the assignment, we was yielding these things.
Yeah. Now we are not yielding. For each document, we're going to index it.
Index it, we are going to call the index doc for each link.
Yeah.
Instead of yielding the document, we will create index the doc. We're going to use HTML document, right?
HTML?
HTML document.
Yes. Also, I saw from the assignment, some of you implemented HTML document, which already passes the content, but still in the crawling, you pass the content again. Therefore, what was the purpose of implementing the parsing here? Okay, so for each page, you just instantiate HTML document, you give the link, we perform the parsing for you as we did before. So there was no need to parse it again or to use Beautiful Soup again. Shall we start with our queue? Initially, in our queue, we passed the current source, and then the current depth, which is 0. And then we have the list of visitors, which is just a set, where we store the visited link, if it's already visited or not. Then we can have like the initial document ID, which is 0, like the first document that we're going to visit, okay? And when this is done, we can start why not Q, Q is empty.
So we need to call the parse, right?
Need to call what?
The parse, because it's not in the initialization.
Remember, we call the parsing with a parameter. If you check.
We didn't call the parsing thing. So it's not in the initialization. When we give the URL to the file.
Yeah, remember here, we are passing, we will start from here, okay? But for some pages, we are just gonna extract the links, okay? And for other pages, we're gonna extract the content itself, okay? Since we are starting by the first page, there's no need for us to try to extract the content because there will not be a content there. This page is just like intermediate page for crawling articles, okay? So we can add one more parameter here and say, for example, just link. By default, this is true. So after extracting the links, if just link, then we return. So we stop there. No need to go further. For example, when I start crawling from this, the first page, I just want to get the links. I don't want to get the content because it's not an article. So we pass the content only for articles. Does that make sense? Yeah. So we come back here. We recall doc is equal to, or we can add it in visited first. Visited dot add. We add the.
So the source is only a link,
The source is only.
a link strictly.
Yeah.
Before URL in.
So we can extract the URL and the current depth. The current depth. So we call q dot pop. So when you pop this, we add the URL to visit it. Okay. And then it's like the same name. Let's call this current. Let's call this current depth. Or URL depth, the depth of that particular URL. Okay, so we add it to visit it. But before adding it, let's make sure that the URL is itself. So if the URL not in visited, then we add it inside visited links, and then we can pursue. Okay. So since we can have like errors when we try to, for example, get the HTML document of that particular URL, we have to also handle this this particular case. So here we can just print unable to load the document. Yeah. We just print this, by the way, and pass. Also, we make sure that we can download. So dot download. If this works, this means that, remember in download, we just call request.get. You make sure that the response is 200, right? Yeah. So if the response is okay, so this means that we can also pass the content. So for this particular document, we'll pass the content and we just links through. Okay, so we just want to get the links first. Okay, so after getting the links, we then for each link in dot anchors. So for each of these links, we make sure that the link starts with what? Yeah, with article. We make sure that it is an
There's
article.
no need for persist, right?
Yeah, we need to persist. It's not mandatory,
Like
but we
for
can decide to
working,
do it.
For the code to work, there is no need for persist. You don't need to save a lot of files.
We don't need to do what?
Save a lot of files.
Yeah, but still. So if you want to persist here, we call dot persist.
So,
Okay.
so one thing, if we go download and it's failed, it's inside the try and like no need to put if, right?
To put if where?
If the download.
We have
It's
also
gonna
exception.
Yeah,
You
it's
know-
gonna fail.
exception handling. So we
Yeah.
have try cache that will cache the top
Yeah.
exception.
Yeah,
It's
I
gonna
mean-
fail. It
I
will
mean,
be,
if you went down, like there's a try and accept, right?
but here it will just
So-
it will just accept, but the code may not be continuing running. So we yes. So we handle the exception here such that it will continue crawling.
Yeah, we can just put continue instead of enable to load the code.
Yeah, this is just printing that I did. You can just put continue. Okay. Yes.
So why are we starting this world? Because we need all articles, right? There's lifestyle, there's
The one
science.
that we have is article and the one here is scoreboard.
Which one that we have?
In my Python, it is like the link is for
You have to pull. You have to
article,
refresh
not word.
because before it was article. Now they updated the website. It is Word.
You updated it?
No, it's not our website. The owner of the website that we're crawling.
No, we need all articles on the website or only
Yes.
political for the world.
Yes. You also have share, different categories. I totally agree with you. Where you have business. Okay. So what we can do, we can make sure that it starts from this, okay? And the next one is in between these categories. Does that make sense? So till now, because before there was like articles / the category of the articles, okay? So till now we are just crawling article in Word, okay? Yeah. So to persist, we also need to specify the collection where we want to persist because the persist functions save it in a particular folder, okay? But before that, we have also to make sure that the folder exists. So if not os dot d dot dot path dot exist, specify the collection path, then we'll just call dot os dot create make d. Yeah, make d. So we create the folder if it does not exist. So when the article starts by this, we persist the article. So we save it in our local disk. And also, remember we have where we index our articles, okay? Docs URLs. So we can call this docs URLs of doc ID, and we spell the URL there. Okay.
So should we put the links in the queue and the visited?
Should we put what?
The links, like for link in doc.anchors, we should put them in the visited and the queue.
Yeah, we do that.
No, we didn't do this thing.
We will do that. The code is not finished yet. Also, now we have to index a document. So for now, we just call this function and later on we will define it. So we have self dot index. We index the document and we specify the document ID, okay? And then we will increment the document ID. First link, second link, next link, and so on and so forth. Also, we have another parameter limit. So the limit is like how many pages or how many documents we want to crawl.
If you reach the limit.
Yeah, if you reach the limit, we stop crawling. If we don't reach the limit, we keep on going. So
We can compare with doc ID.
What? So if limit not none, so if you specify the limit,
We can compare the limit with the doc ID. Because doc ID is incremental. So the number of
yeah,
One question, another question. Like we are looking if the link inside the anchors is going to start with this thing, we are going to do doc persist. The same doc that we are in right now, we didn't change it. Like it's the doc that we are like in the same node right now. And if we have like 10,
We index it.
no, I mean, like look to the doc dot persist.
Yes,
Yes, this doc, which doc is this?
the current document.
The current document.
Yeah.
Like for the for loop, how many times is going to be persisted? The
Not-
same doc.
Not the same document.
We are not going to change it.
Because remember, we pop it from the queue.
Yeah. But like
For the next loop, you mean for which for loop?
for loop, not the while. This for loop is for each link in this document, right?
Yes, okay, so yeah, you're right. So we can persist this right after. Okay. Yeah, thanks. So if we didn't reach the limit, or we can use, as he said, like if the doc ID is less than the limit, okay? But just here, the doc ID may be also strings, okay? So let's keep this flexibility that we have. Because we can also randomly generate the doc ID, like unique IDs. So if the limit is specified, we check if we have limit, we decrement the limit, okay? And then if the limit is equal to 0, then we stop crowd.
But should we like put it in the while loop? Like, why are we putting it inside the for loop? It's like an extra like, condition each time it's going to.
Each time that we find a new link, that will be crowd.
I mean, you should put it like after persist, like not in the persist loop, not in the like.
The limit is counting the number of documents that we, okay?
Yeah.
So maybe the first page contains just 2 documents. We crowd them and we stop there. Okay?
And we serve the index is also can be done multiple times.
What can be multiple times?
Though serve the index, we are going to do the indexing for each document inside the.
Yes. We're indexing all the documents. Okay. So next, we make sure that if the depth, if we didn't reach the max depth, if this is less than depth, okay. What do?
We add them to the visit. We add them to the queue.
Add them to the queue, right? Yeah. But should we add all the links in the queue?
We will add the
Just the
links
links
that start with.
Exactly. So we
because
can
have
filter
the
them.
self-doc URLs.
We can like filter them before like putting them in the queue, right?
Yeah, we can.
So we don't need to like check it.
Like this.
Yeah, what's the point?
Like we can do the URL diff is like we can do it in the beginning because if the diff is like we can make this one +1 and we don't have to do this. It can be at the top.
Hey, this if we start from 0, we cannot from +1. Also, we have to filter the links, okay? So, for example, we can call like we don't have variable links, right? So just imagine that we have filter. We define the filter function. Let's say this is appropriate links, okay, of doc dot anchors. Okay.
Filter for
What?
really have to start. Yeah, like if you are filtering, you need to remove it.
No, you'll see why. Because one article may not be part of this particular place, okay, but it's found somewhere else in the website. Okay, so here we filter, we make sure that it is inside our domain, okay, and it is not PDF, MP3, or all these formats. Okay, does that make sense?
But like we get it from the queue, we get this from the queue, right?
Yeah, so let's call this valid links. And then for
And we are
and then for A in valid links, we add in the queue now. Okay, queue dot add.
We need to add them to the visit.
You need to. Not yet. They are not visited yet.
It depends on the type of the.
Yeah. So we have this and where depth. This one.
That's like checking for the link when we before putting them inside the queue. Why do we need to check it again? I don't understand.
Okay, let's implement this appropriately. So def appropriate link, we have self, and we have link. Okay. So if not this link, but start with, if it's not in this domain, okay, we return false. This page is not inside the page of the article, the website of article that we're handling. Okay, but it may be inside and contains link to article that we can handle. Okay, so that's why we also filter that there. Also, if let's check the ending. So if we get the last four things, if it is inside, let's say we have dot mp3. What? Yes, yes, -4. If we have mp3, we have PDF. What else do we have?
Sometimes we can get it like for characters extension.
Huh?
The text is valuable.
No, because we are just handling HTML documents.
Like it might be JPEG.
Yeah, it might be image.
Well,
It may be PNG.
like, I mean, if it is JPEG, it might be 4 characters. But right now, it's not going to end in JPEG because we took -4.
Yeah, this means we need a more straightforward way to, a more like robust way to extract extensions.
Yes, so like for me, like the assignment, I used this thing that you implemented at the end, at the beginning, to take the extension on the file, using the same thing that you put, but like I got a -1 for this.
Because the implementation didn't expect you to ignore those files.
Yeah, but like
That
you
was
said,
just
it's the same
document.
thing.
That was just document.
Yeah, but like this thing is it's used in the last block of code. Like I just copied it from the last block and used it again.
That time it was for HTML documents. Like each assignment, each task has like the requirements, okay? So we should follow the requirements. So now the most important part for this lab, and then you will continue the next if we don't have much time left. Document index. So remember we have index document share. So now I have to build document index. So from the document, now we need to pass the content. Okay, after passing the content, we extract all the tokens. Okay, so why this is not calling the function? We put it in the wrong place. That was in the wrong place. Okay, should be here. What?
The first condition.
After first what?
The first condition says just false.
This is Issue the control.
Partly it starts with
Yeah, that's my mistake.
and maybe the second one double column should be after -1. Check the last 4.
The double what?
The double column, the index. Yeah. After
Here?
-4 to check.
The follows, yeah. Yeah.
And also, can you please add? sorry.
Yeah.
Can you please add dot to PDF 16?
Yeah, thanks. A lot of mistakes. Sorry for that. Well, so let's implement this part. So when we have the document, first we call document.parse. Okay. And just links is false now because we need the content. Okay. And then remember, we have the preprocessor here. Okay. So here we have terms is equal to self dot preprocess of document dot text. If I'm not mistaken, it is inside document dot text. Okay. What I said. What yeah, document dot text. Okay. So now we also need to count the number of occurrence of each term inside the document. Remember how we're going to save it. In the term, the first thing is the correction frequency. Okay, how many times this term occur in documents? The second thing is document ID and the doc frequency of this particular term. That makes sense? No. The inverted index. Maybe we can stop. Let's go to a whiteboard session for some seconds, and you will be able to finish this by your own.
So, sir, are we going to get the solution of this lab?
Yes, sure.
Thank you very much.
I forgot my Type-C cable. Anyone have it? No, Type-C to USB. Okay, thank you so much.
One last question. Are you recording the lab?
Yes.
Oh,
So let's have like whiteboard session. How much time left do we have?
-2.
Okay, let's be fast. It seems like the recording stopped since. Back to the. Yeah, very fast. I wanted to use the
Like you wanted to record it.
to record it also for you.
maybe you could click that green button.
Which green?
Do stop sharing.
Yeah, it's here. Thanks. Okay, guys, so for the inverted index, we have like, you have several documents, document 1, document 2, and document 3, okay? Let's say the first document is today, ER, okay? And here we have, we are happy today. It's just example of documents. The document 3 is we had lecture today. So if you want to build the inverted index from this, for all the documents, you have to extract the tokens, normalized with stemming and all these things, okay? And then you have to build a vocabulary. For example, I have the term today. So that will be like a term in my vocabulary that we have today. And then I have, for example, ER. I will have ER as a term from vocabulary. I have we. I also have R. I also have today. I have today already. I also have, let's say, lab. And so on, okay? Now for each of these terms, I'm going to build what we call the posting list. The posting list will just tell me like the indexes of documents that contains this particular token. For example, today, I have today in document 1. So I just put at the edge of document 1. I also have today in document 2. So I will have document 2 there. I also have today in document 3. So I have today everywhere, okay? For the next token, I also build the posting list. So we have ER. The first document has ER, so I have the index of the document there. The second document does not have, so I skip it, and the last document has ER, so I have this, okay? It is 3, yeah, the index 3. And the last thing is we. I have we in the second and the third document. So you build this and so on and so forth, okay? So when you have the inverted index built, we can answer queries as today ER lab, okay? Or we can answer queries like today's lecture, okay? If I have today's lecture, we find the document that is relevant with that, we have, first we have today and lecture as our tokens. So we're looking for the document that contains today's and lecture. First thing to do is to find the term for today and extract the postings, okay? So I will have the term for today. I will have the posting 1, 2, and 3, okay? And then I will have lecture, extract the term for lecture. We see that only document 3 contains lecture, right? And I will have the second term with 3, okay? And then I intercept those 2 stemmings, okay? And then I will return the documents that match those 2 posting lists. So I will see that only document 3 match that. And I return document 3 as the answer of the query. Does that make sense?
So just use it to,
That's why we call it Boolean retrieval, because it's just to answer Boolean queries. One, the document that contains today's and lecture. We explore the inverted index and then extract the terms of the query, okay? Next, extract the posting of each term and then intercept them.
just to check when our 2 words using together.
Yeah,
in some-
in some of the document, using this indexing.
So if it's Boolean, that means if the query has some word, which is like suppose there are 10 words in the query and 9 of them match with the document. The last one doesn't, so it will not return anything.
Yeah, it will not return anything.
It has to completely match the query. I mean, the query and the what is that? The words in the query.
Because
have
it
to
is
be
N, it is N.
and, right?
Today and this. If it is today or,
Yeah.
the intercept will also be built accordingly. Okay? And also here, the posting list can be implemented as an array or a single linked list. Okay? Depending on the implementation, the time complexity of replying to the query will change. Because for linked list, it is easy to add and remove elements. If it is an array, it is easy to access elements. Because you have linked list, you have to go through single like linear time. Okay? We don't have much time left. There are also the formulas for scorings, where you have document time frequencies. Okay, you also have the MB25. Hopefully we'll cover it in the next lab, but for now, keep up implementing the rest of the lab. If you have any question, just write the message in the chat or in the personal message, okay? So that's it for today, thank you. Yes, sure. You asked me last time, right? No, it was you. What was the last time?
It was today at 4.
Yes, today at 4.